Assembling the Club Car FE350 Accelerator Series engine. Presented by Attica Equipment Limited and Porcelato Engineering, partners in club car performance.
Accelerator Series 290s, 350s, and 400s all feature advanced timing, increased compression, and lightened flywheels. So we'll get started by installing the flywheel seal. What we do is we're careful to install this seal at the right depth. If you notice, there's a return hole here, and if the seal is over-installed or pushed in too deep, you can restrict that, and then it'll back up behind the seal between the oil gallery, the pressure side, and this hole, and it'll force this seal to leak, or force oil past this seal. So what we're going to do is just install this seal now and get it in at the right depth. The tools that do that they have a shoulder that establishes that depth. So here's how we do it. With the flywheel side seal installed, we're now going to transfer this engine, or this block, over to the assembly stand, and we move the engine crankcase cover into this position. We're going to build that up next. The next step is we'll install the power takeoff side seal, or the clutch side seal. We've already installed the bearing. We tend to do that because we do have some appearance group options on these engines. This one has the Harley-Davidson wrinkle finish on it, but sometimes they're powder coated, and in installing this bearing, we preheat the case to install the bearing. We don't want to damage any of those appearance group finishes. So now we'll go ahead and install this seal. We have made a tool, once again, with a shoulder that establishes a depth to install that, and it's a little bit different from the OEM. The cranks, when they're in service, end up with a small mark cut into the crank, essentially, from the seal, or worn in. We just moved the seal about 20 thou to establish a new position, and it just guards against leaks. So now we'll go ahead and get that seal out and install it. Okay, we have the cover flipped over now, and what we're going to do is install the oil level switch. Now, this is about the last level of performance engine that we installed this switch in. We have it deleted in our higher RPM engines. We grind custom camshafts and offer custom push rods and valve springs, etc. for these engines. On our dyno, we've had FE350s up at 6,800 RPM, and what happens is in some of those engines is we develop a little bit of vibration in the engine. These tabs are very, very weak, and we've had these come off and actually take an engine out because it's flopping around inside the engines. We also delete the counterweights in the higher RPM engines. The counterweights in the oil switches are only used to engines to 4,000 RPM maximum. So now we'll go ahead and install this switch. We pre-assemble the rotating assembly almost in a group. This is a huge time saver. The flywheel side link arm will come off. There's a thrust washer here that helps support this link arm, and this will fall off. And if you try and do this all sort of one part at a time and try and get this in the crankcase, it's a real hassle. So if you can imagine, you don't need these stands, but if you just had a nice something soft laid out, you assemble all these components with the counterweight pre-installed, and pick the whole unit up as a group and drop it right down into your case, which is now horizontal. We'll show you how we do that. Okay, so I've pre-lubricated these journals. I'm pinching this whole assembly together. I'm now going to lower the whole thing into the engine case at one time. So we've got the washer, the link arms, the counterweight, everything together. It's that simple. It's a huge time saver. Next, we install the counterweight pivot. The counterweight pivot is sealed into the case with an O-ring. One of the most common questions we get from folks at home assembling their own engines relates to the orientation of the piston and the connecting rod. The manual, when it discusses this particular thing, makes reference to made in Japan, and that adds another layer of confusion, because you'll see this is an FE350 rod. Both rods are orientated similarly, with the bolts sort of facing upwards. We've got made in Japan here, and it's on the opposite side of the FE350 rod. So the most important thing to remember is this simply. If you've got an engine that turns when viewed from the clutch side clockwise, you want to orientate the L that's on the piston crown towards the actual flywheel. If you've got an engine that turns counterclockwise, you want to install that piston on the rod with the bolts facing up in both scenarios towards the back or top of the engine where the starter generator would reside, so they're facing up. You're going to want to have that R facing the flywheel. So that's the easiest way to remember it. If you have any confusion or questions on that, give me a call. I'll go into a little more depth on the subject. It relates to the piston pin offset, and it is important. So we just thought we'd cover that with you. Well, we've installed the piston on the rod, and just a note on that, always purchase new circlips here. There's this tendency to reuse these, but invariably when they're removed, they're always somewhat distorted, and it's cheap. Call it a one-shot use. But I've installed the oil expander in the rails. Relatively easy stuff. One little kind of area that can add some confusion in the assembly of one of these engines is many ring sets are marked that give you an orientation to top or give you some indication on how to install the ring or even the position. All these rings are based on a nodular iron substructure, but we've got a friable chrome coating on the top ring. So you'll notice that the top ring is much more silver, and the second ring, or the scraper ring, is kind of a dull, just nodular iron finish. Now, there is no orientation for up on these because the backs of the rings, if you look in the back of both of them, they're square cut. So you don't have to worry about that. Just make sure you get the top ring in the top groove and the scraper in the second groove. Okay, we've loaded the piston and rod assembly in a fixed ring compressor. We use these here at Porsolato Engineering. They're machined specifically for each bore size we deal with. They're just a faster kind of, in some cases they're a little bit better, but you don't need one of these at home. If you're using a standard ring compressor, low friction type, or a band type, that's fine. The thing you want to remember is that it takes almost no effort to install the piston. After we bore the block, we'll go ahead and put a little bit of a radius to help you get it assembled, but you shouldn't have to work to get this piston and rod assembly in. So we're just going to use the back end of a 3/8 ratchet and just tap that in. It's just that easy. If you find yourself fighting with it, stop, reload your ring compressor, make some adjustments. It should be really easy. We'll now torque this up. We've pre-lubed our camshaft journals and lobes, and we're now going to install the cam. There's a dot on the cam gear as well as a corresponding dot on the crank gear, and we want to have those two lined up. Now just a note on the actual, there we go, those two are aligned. That's important. This cam gear is the riveted type. You want to carefully inspect these rivets to make sure that they haven't begun to fail. This one's still in real good shape. We have a program where we offer a bolted cam. It's an option on the first stage performance engine, but any of the engines that use our double valve spring or the high rev engines where we're slightly elongating the cam gear to move our camshaft centerline around, they are always bolted as standard. But at this level, this is okay, so we'll leave it at that. Now there's a couple of shims that you want to be aware of. On a FE350, we have a cam shim, and we also have on the FE290 and 350 and 400, they always have a shim to set the crankshaft end plate. FE290s do not use this shim, so you don't have to worry about it. But if you're taking apart an FE350, make sure you retain these two together. If you send us a cam for a custom profile, you can retain this. We'll send your cam core back. This shim will still work with your case. If there's ever a problem with the camshaft end play or the crankshaft end play and you're having difficulty establishing it within specifications, give us a call or send us an email. We'll help you through the process. But in this particular engine, we're reinstalling the OEM or original crank spacer as well as the camshaft shim. We now install the oil pump strainer. If they're really distorted and they don't do a really good job of sealing the box that they live in, you could replace them. This one's still in pretty good shape. So it just basically goes in with the 4 little feet pointing down. Just push that into position. Then we install its little cover plate with a couple of small cap screws. They're very small, so we do these by hand. We don't use our small electric gun on them or anything. It's just, they're too minute. And there isn't really a torque spec for them. I mean, they're just snug. Just use your judgment there. They don't have to be over tightened. We'll now move on to the installation of the engine side cover. Okay, we'll now install the crankcase cover. The crankcase cover gasket is in position. We don't use any sealers on this. No silicone is required or aviation. There's a temptation to seal all these surfaces. If you've done a good job cleaning and scraping away the old gaskets, you just need to lay this in position and you're fine. So we've pre-lubed the bearing. We always replace this bearing, by the way. It's something you should do. And pre-lube the saddle for the cam. The shims are in place. We're now going to install this cover. There's 2 studs used on a club car. They go in this position near the cylinder, sort of towards the top. So one here, one there. Their purpose is to retain some straps that hold the electrical for the engine in position. The rest of the cap screws are just occupying the other bores, but pay attention to those 2 right there. Now what we do is we just gun these into position, and then we'll go ahead and torque them and swing the engine back into the vertical position and check the crankshaft end plate. So we've got a dial gauge set up. We temporarily put the oil pump cover on. We haven't got the oil pump group assembled yet. It's just a convenient spot to mount the mag base of the dial gauge. Now you can check your end play. The service limit for an FE350/400 is 14 thousandths of an inch. We set them up much tighter, usually in the 5 thousandths of an inch range, but we just wanted to see, to show you a way of doing it at home without any fancy fixtures or anything like that. Okay, we're building up the oil pump group now. Some of the key components here are going to be your oil pump gears, both drive and driven. The early FE350s did not have this small filter here. It's an additional level of filtration for the oil supply to the hydraulic lifters. They have some very fine clearances, and it's just another additional step to keep those works fine. So now the thing is, we always install the camshaft first and then the oil pump, and not in the reverse order. If we build up the oil pump first and then try and install the cam, we have a high probability of misaligning these tabs. And the cam, when you press the install the side cover, you're going to push up against the cam, and the cam will push up against this misaligned tab and damage the cover for the oil pump. So we always have the cam in first. So the tab's there, we've got the tab here, we're going to install this. It's good now. We're going to install the oil pump driven gear. We're also going to cover that up with this little plate here. We don't want to forget that. Then we're going to build up the oil pressure relief. The spring goes in first. We have a check ball, and then this little cover, we have these two holes and this reduced cross section here that faces out. And then we'll finish up that group by installing a gasket and a cover. Now, once again, when you're dealing with some of this or the smaller hardware, there is a published torque specification for this stuff. We can provide it, as I say. Just hit us up by tele or email. But if you don't have a very fine inch-pound rated torque wrench, these are just snug. We don't want to over-tighten any of this stuff. It's kind of counterintuitive, but just snug will do the job. You really don't have to go overboard here. Okay, we're about to install the flywheel now. It's a little bit difficult to see, but we've got a cutaway on this keyway. The purpose for that is we have a number of different styles or versions of this depending on what engine we're equipping the keyway on, and this allows us to modify the ignition timing. In a standard automotive engine, you can accomplish that through the distributor. Our only opportunity here is to move the flywheel in relation to the crankshaft. Now, on this first level of performance engine, the Accelerator series, we're setting this timing, this total timing, at about 29 degrees. But on some of the higher performing engines, the ones where we're stretching out the RPM range into the 6,000 range, we do have a different timing curve for that, but it's a little bit proprietary. So anyways, we're going to install this flywheel now, and we'll show you how we do this. Now, when viewed from the clutch side of the engine, the rotation is clockwise. So what we're wanting to do right now is our coil is going to mount here. So we've already previously adjusted the keyway, as we know previously where we need to be. We want to just move this flywheel up against that shoulder, and that gives us our advance. So we'll just hold the crank. We're already pushed up against the shoulder into the advanced position. We simply install the nut and the washer, and we'll torque that up. And then we'll double check that with the torque wrench. We're torquing that right in around the 100 foot-pound range, but that's generally all it takes. Now we've got the timing advanced in this. It's set up ready to deliver a little higher level of performance. Okay, with the engine back up in the vertical position, we're now going to get ready to install the coil. We'll show you how that's done. Okay, we've set the clearance, the air gap between the coil and the flywheel mag. That's 12,000ths of an inch. We use a non-ferrous material so it doesn't stick, and that gives you a real good reading. It's difficult to do with a standard feeler gauge. It's possible, but this is the better way to do it. Now, there's a wire that gets connected. You don't want to forget this and get your tin on and realize you haven't put this wire on. This goes down to your advancer unit. There's a small clip on the block. It's hard to see with this one being black, but the wire comes up, around to the coil. Don't forget that. Now, one thing I did forget is when I installed the flywheel, I forgot to mention that this is a lightened flywheel. That's the third aspect of the Stage 1 performance engine, where we have a slight increase in compression because we've surfaced the head. We'll show you that in a little bit later. We've got the timing advance, but we also lighten the flywheel. Now, it's a little bit of a challenge to see. There's a lip that's on the back of these flywheels. Now, what we've done is we made up a fixture that allows us to put the flywheel in our lathe, and we essentially machine the back half of this off, and we get right up to this lip here that's close to the weight. So we machine this off, and what that does is it reduces the flywheel weight by about 2.7 pounds, and we found that to be a real simple performance improvement. It's as I say, it's applied to all of our first level performance engines, the Accelerator series. And further to the lightening of the flywheel, the OEM does have some balance holes that are applied to the back of the flywheel. So what we're doing, once we've lightened the wheels, we do them in a lot. We've got a bob crank set up. We have a bob weight that we put on here for the 350 as well as for the 290. And what we're going to do is we have a balancing fixture. We install the flywheel, and then we roll that flywheel around at about 1,000 RPM and check the balance. So they are rebalanced after they're lightened. So now we're getting ready to install the cylinder head. One step that we didn't mention when we were putting the crankcase together is that in an FE350, it uses a solid follower. It's a mushroom style follower. The tappets, or those followers, have to go in first. That is, they go in with the camshaft. They go in first and then the camshaft secondarily. The FE350 uses a hydraulic lifter as well as the 400, and they can be installed after. Now, unfortunately, if you forgot that in an FE350, if you didn't get those, or sorry, 290, if you didn't get those tappets in and put it all together, it's got to come apart again. There's no way to put the tappets in from the top, only on the FE350. What we've done is we've cleaned up these surfaces with brake clean. This block was also lapped a little bit. We do that on a surface plate here just to make sure that we don't have any warpage. We can always correct this here. We can zero deck these blocks. We're now going to install the dowels, the cylinder head dowels, the lifters, the push rods, and the cylinder head. We put them on as a complete unit. This is a cylinder head that's pre-assembled to go on. When there is a surface preparation, i.e. the paint or powder coating, we will spot face off the bolt areas to get a more accurate torque. Now, this particular head has gone into our lathe for a surface. I'm just going to grab a fixture in the next shot and talk about the cylinder heads as far as the assembly at home and actually how we achieve some of these increases in compression. So I'm just going to get this cylinder head assembly on. We'll talk about the torque, etc. We're going to install the push rods at the same time, and we're going to push up against the lifters. Now, you're going to find that the lifters take probably 15 minutes to pump back down. They're sort of pumped up. The valves are held off their seat until they bleed off. So we just wanted you to see that, and then we'll, as I say in the next shot, talk a little bit more specifically about the cylinder head and the valve springs and that assembly. So we're just going to go ahead and get this on, so we'll get back in a moment. All of the FE series engines from Kawasaki use a shim style head gasket. There is no surface preparation available or recommended for this. It's a simple clean the surfaces and install. Just a little more detail on the FE series cylinder head. When you buy your gasket kit from Attica Equipment, it's going to include a set of valve seals. Now, if you install a valve seal without the spring seat in place and try and remove the valve seal to reinstall it, it won't work. So the first thing, because this won't go over the seal, the first thing you want to do when you're assembling your head, if you're doing this at home, is get the spring seats installed, and then you install the valve seals. Now the valve seals go on, we use a plastic installation tool. It's a very, very light pressure. You'll feel them click into place. If you don't have the custom tool like we use, you can use a socket, a right size socket. You don't need to hit the valve seals on, they simply just push over the top of the guide. Now another detail here is the valve springs themselves are progressively wound. It's a little bit difficult to see, but there's a little tighter coil at the bottom of the valve springs. The tighter coil at the bottom of the valve springs faces down. And one other detail on cylinder heads is this is the fixture we use for putting cylinder heads in our lathe. Now, this just adapts any of the FE cylinder heads to the lathe, and then we're able to run the tool across the surface them. We typically take about 18 to 20 thou off these cylinder heads for the Accelerator Series engine. It gives us about a half a point of compression, a little better engine performance. When we get into the higher performing engines, some of our engines, we've sold engines in excess of 11-to-1 compression. We actually use a custom piston in those engines. So just for the Accelerator Series engine, this is the fixture we use for surfacing them. Okay, we're now going to install the oil filter adapter and the valve cover. The valve cover is sealed by a gasket here. It's included in the kit, of course. And it also includes a couple of O-rings. These O-rings go underneath the head of the valve cover bolt. And that's an important little addition. You'll have a leak if this isn't replaced. But you'll notice these bolts look very similar. If you, by accident, install the shorter bolt on the filter adapter, it'll only be engaging a couple of threads. And as you go to tighten it, you'll damage the block. So make sure that the short bolts are used for the valve cover, and the longer bolts are going to be used for your oil filter adapter. Now, once again, all these gaskets and seals are included in the kit from Attica Equipment. And now we're going to install the tin. We just leave all this hardware just relatively loose until we get all of it together, because it requires a little bit of movement, a little bit of adjustment. Just a quick note on spark plugs. We see a lot of customer vehicles come in with the gap set at 35. We find that the best performance is delivered when the gap is set between 27 and 32 maximum. We also use a little bit of anti-seize on the threads. We've got dissimilar metals here, and you know, over time there's a little bit of a galvanic action and we can damage the head. So we don't want to have to do unnecessary repairs. It's a little bit of an ounce of prevention in this case. We also torque the plugs up here. It's easy to just guess, but you've already got your torque wrench out. You've been doing all this other work on the engine with the torque wrench, so we're going to set this to 18 foot-pounds. Perfect. Now the next time you see this engine, it's going to be on the dyno, so we're going to wrap it up for now.